The usual hypothesis tests you learn in the statistics course have an underlying assumption of normality behind them. Some variable or some difference between variables is assumed to be at least approximately normally distributed. Although these tests often work well even when the normality assumption is violated to some extent, a number of non-parametric tests have been developed that do not rely on normality. These tests are not as powerful as the usual parametric tests, so they shouldn't be used when the normality assumptions are satisfied, but they provide a useful alternative otherwise. StatTools implements 3 of the most common non-parametric tests. These 3 are shown here. The first 2 tests are for testing a single variable or the difference between 2 paired variables. The last test is for testing the difference between 2 populations, such as males versus females. These tests will be illustrated with the data shown here. All 4 of the numeric variables in this data set have distributions that are skewed to the right, so it makes sense to use non-parametric tests on them. The sign test. The sign test is used to test the median of a selected variable. It is not a very powerful test because the only information it uses is whether each observation is above or below a hypothesized median. As an example, the dialog box shown here can be used to test the alternative hypothesis that the median salary in the population that this data set is a sample from is greater than $50,000. Here are the results. The sample median is 53,700, which is indeed greater than 50,000. And 540 of the observations are greater than $50,000. Based on this count, the p-value is less than 0.01, so the alternative can be accepted at all the usual levels of significance. Note that the format for this test is unstacked. If you set it to stacked, as shown here, you can select a categorical variable and a numeric variable. However, this does not compare the males to the females, as you might suspect. It simply tests the median separately for each gender. There's the test for females, there's the test for males. The sign test also has a paired sample analysis item in its analysis type dropdown. This is useful in a situation, say, where students take a course and you have before and after test scores for each student. Then you would choose 2 variables, before and after, in the dialog box, and the test would be on the median of their differences. This version of the test isn't illustrated here. Wilcoxon signed rank test. The Wilcoxon signed rank test has exactly the same purpose as the sign test, but it is a more powerful test because it uses more information from the data. Instead of just using the sign for an observation, that is, whether it is below or above the hypothesized median, it uses the signed ranks of the observations. These are based on the ranks of the values below the hypothesized median and the ranks of the values above it. The dialog box you see here runs exactly the same test on the median of salaries as was run earlier with the sign test. The results are essentially the same as before. There is enough evidence to conclude at all the usual significance levels that the population median salary is indeed greater than $50,000. As with the sign test, the Wilcoxon signed rank test can be used in a paired sample setting to test the median, say, of the difference between before and after tests. In fact, this is probably its most common type of use. the Mann-Whitney test. The Mann-Whitney test is a non-parametric alternative to the popular two-sample t-test for testing the difference between two means. It is actually used to test the difference between two medians. As you can see in this dialog box, there are two versions of the test, depending on how much you are willing to assume about the shapes of, say, the male and female distributions. The median version, the one illustrated here, results in a more powerful test, if its assumption is warranted. So I will compare spending amounts for males versus females. I'll make this a two-tailed test, and I will use the median version. The assumption is that the test will be on the female minus male difference. This dialog box lets you reverse it if you like. Here are the results of the test. The median spending amount for males is much higher than the median spending amount for females. And this is reflected in the very small p-value for the test. There is convincing evidence at any of the usual significance levels that the medians for the two genders are not equal.